In a frequency distribution, the mid-value of a class is 15 and the class interval is 4. The lower limit of the class is? The options are 10, 12, 13, 14. The correct option is 13. The lower limit of the class is 13, which is found by subtracting half of the class interval, that is 4 by 2 is equal to 2, from the mid-value, 15. Lower limit equals mid-value minus half of the class interval. Equals 15 minus 2. Equals 13. Hence, the lower limit of the class is 13. The mid-value of a class is 42. If the class size is 10, then the upper and lower limits of the class are. The options are 47 and 37, 37 and 47, 37.5 and 47.5, 47.5 and 37.5. The correct option is 47 and 37. Because the upper limit is 42 plus 5 is equal to 47 and the lower limit is 42 minus 5 is equal to 37, where 5 is half of the class size, 10 by 2.
Consider the following statement. If in a frequency table, the class intervals are 40 to 44, 45 to 49, 50 to 54 etc., then when made continuous, they will be 39.5 to 44.5, 44.5 to 49.5, 49.5 to 54.5 etc. This statement is, the options are, wrong as 40 to 44 actually means 40 to 44.999, etc. and hence when made continuous, they will be 40 to 45, 45 to 50, 50 to 55 etc. Wrong as there are no readings between 44 and 45, between 49 and 50 etc. and hence the correct intervals are 40 to 44, 45 to 49 etc. Correct. Although the interval is actually 40 to 45 etc., there is the possibility of recording errors at each interval, namely 40, 45, 50 etc. and hence the intervals should be taken as 39.5 to 44.5, 44.5 to 49.5, 49.5 to 54.5 etc. Correct, because the mid-values of 40 to 44, 45 to 49, 50 to 54 etc. and 39.5 to 44.5, 44.5 to 49.5, 49.5 to 54.5 etc. are the same. The correct option is, wrong as 40 to 44 actually means 40 to 44.999, etc. and hence when made continuous, they will be 40 to 45, 45 to 50, 50 to 55 etc. Because the original class intervals 40 to 44, 45 to 49, 50 to 54, etc. actually mean 40 to 44.999, 45 to 49.999, 50 to 54.999, and so on. Therefore, when made continuous, the correct intervals are 40 to 45, 45 to 50, 50 to 55, etc.
The number of times a particular item occurs in a given data is called its. The options are variation, frequency, cumulative frequency. None of these. The correct option is frequency. The following marks were obtained by the students in a test: 81, 72, 90, 90, 86, 85, 92, 70, 71, 83, 89, 95, 85, 79, 62. The range of the marks is. The options are 9, 17, 27, 33. The correct option is 33. Because in this case, the highest mark is 95 and the lowest is 62. So, the range is 95 minus 62 is equal to 33. The width of each of 9 classes in a frequency distribution is 2.5 and the lower class boundary of the lowest class is 10.6. Which one of the following is the upper class boundary of the highest class? The options are 35.6, 33.1, 30.6, 28.1. The correct option is 33.1. To find the upper class boundary of the highest class, we need to add the width of the classes, 2.5, to the lower class boundary of the lowest class, 10.6, 9 times. 10.6 plus 9 times 2.5 is equal to 10.6 plus 22.5 is equal to 33.1. So, the upper class boundary of the highest class is 33.1. Let L be the lower class boundary of a class in a frequency distribution and M be the midpoint of the class. Which one of the following is the upper class boundary of the class? The options are M plus L divided by 2. L plus M plus L divided by 2. 2M minus L. M minus 2L. The correct option is 2M minus L. This is the upper class boundary of the class. Explanation. M equals L plus U divided by 2. Rearranging to solve for U, upper class boundary. Upper class boundary equals 2M minus L. If the arithmetic mean of 7, 5, 13, x and 9 be 10, then the value of x is. The options are 10, 12, 14, 16. To find the value of x, we need to calculate the sum of all the numbers and divide by the total count of numbers. The arithmetic mean is given as 10, so we can set up the equation. 7 plus 5 plus 13 plus x plus 9, divided by 5 is equal to 10. Combine the constants. 34 plus x, divided by 5 is equal to 10. Multiply both sides by 5. 34 plus x equals 50. Subtract 34 from both sides, we get x equals 16. Therefore, the value of x is 16. The arithmetic mean of the set of observations 1, 2, 3, up to n is. The options are n plus 1 over 2, n over 2, plus 1, n over 2, n minus 1, over 2. The correct option is n plus 1, over 2. Because the arithmetic mean of a set of consecutive integers from 1 to n is equal to the average of the first and last terms. In a monthly test, the marks obtained in mathematics by 16 students of a class are as follows: 0, 0, 2, 2, 3, 3, 3, 4, 5, 5, 5, 5, 6, 6, 7, 8. The arithmetic mean of the marks obtained is. The options are 3, 4, 5, 6. To find the arithmetic mean, we need to add up all the marks and divide by the number of students. 64 divided by 16 is equal to 4. So, the arithmetic mean of the marks obtained is 4. Out of 100 numbers, 20 were 4s, 40 were 5s, 30 were 6 and the remaining were 7s. The arithmetic mean of the numbers is. The options are 5.3, 5.4, 6.1, 6.5. Let's break it down. 20 numbers were 4s, so the sum of these numbers is 20 times 4 is equal to 80. 40 numbers were 5s, so the sum of these numbers is 40 times 5 is equal to 200. 30 numbers were 6, so the sum of these numbers is 30 times 6 is equal to 180. The remaining numbers, 100 minus 20 minus 40 minus 30 is equal to 10, were 7s, so the sum of these numbers is 10 times 7 is equal to 70. Now, add up the sums. 80 plus 200 plus 180 plus 70 is equal to 530. There are 100 numbers in total. Now, divide the sum by 100. 530 divided by 100 is equal to 5.3. So, the arithmetic mean of the numbers is 5.3. The mean of the values of 1, 2, 3, n with respective frequencies x, 2x, 3x, nx is. The options are n plus 1 by 2, 2n plus 1 by 6, n by 2, 2n plus 1 by 3. First, we will construct a table having 3 columns, one for values of x, second for their respective frequencies, and third one for the product of the first and the second column. Then, we'll sum the second and third column, putting the values of the sum of third column in the numerator and the sum of the second column in the denominator of the formula of weighted mean. At last we'll get 2n plus 1 divided by 3. While dividing each entry in a data by a non-zero number a, the arithmetic mean of the new data. The options are is multiplied by a, does not change, is divided by a, is diminished by a. The correct option is divided by a. If the mean of 5 observations x, x plus 2, x plus 4, x plus 6, x plus 8 is 11, then the mean of first 3 observations is. The options are 9, 11, 13, none. Let's break it down step by step. The mean of the 5 observations is 11, so we can write x plus 2, plus x plus 4, plus x plus 6, plus x plus 8, divided by 5 is equal to 11. Combine like terms. 5x plus 20, divided by 5 is equal to 11. Multiply both sides by 5. 5x plus 20 is equal to 55. Solve for x, we get x equals 7. Now, let's find the mean of the first 3 observations x plus 2, plus x plus 4. For this, x plus 2, plus x plus 4, divided by 3. Substitute x equals 7. 7 plus 9 plus 11, divided by 3. Equals 27 divided by 3. Equals 9. So, the correct answer is 9. If the mean of 4 observations is 20 and when a constant c is added to each observation, the mean becomes 22. The value of c is. The options are -2, 2, 4, 6. Let's denote the 4 observations as x1, x2, x3, and x4. The mean of the original observations is 20, so we can write x1 plus x2 plus x3 plus x4, divided by 4 is equal to 20. Multiplying both sides by 4 gives x1 plus x2 plus x3 plus x4 equals 80. Now, when a constant c is added to each observation, the new mean becomes 22, so we can write x1 plus c, plus x2 plus c, plus x3 plus c, plus x4 plus c, equals 88. Combine like terms. x1 plus x2 plus x3 plus x4 plus 4c equals 88. Subtract the original sum from this equation. For c equals 88 minus 80. For c equals 8. Divide by 4. c equals 2. So, the value of c is 2. In a class of 100 students, the mean marks abstained in a certain subject is 30, and in another class of 50 students, the mean marks obtained in the same subject is 60. The mean marks obtained by the students of 2 classes taken together is. The options are 40, 45, 48, 50. Let's calculate the total marks for each class. Class 1, 100 students mean marks equals 30. Total marks equals mean marks times number of students equals 30 times 100 is equal to 3000. Class 2, 50 students mean marks equals 60. Total marks equals mean marks times number of students equals 60 times 50 is equal to 3000. Now, let's combine the 2 classes. Total marks for both classes equals 3000 plus 3000 is equal to 6000. Total number of students equals 100 plus 50 is equal to 150. Mean marks for the combined classes equals total marks divided by total number of students equals 6000 divided by 150 is equal to 40. So, the correct answer is 40. The mean of 100 observations is 50. If one of the observations, which was 50, is replaced by 40, the resulting mean will be. The options are 50, 49.90, 70, 40. To find the resulting mean, we'll calculate the total sum of the original 100 observations and then adjust it for the replacement. Original total sum equals mean times number of observations. Equals 50 times 100. Equals 5,000. Replace 50 with 40. New total sum equals original total sum minus 50 plus 40. Equals 5,000 minus 50 plus 40. Equals 5,000 minus 10. Equals 4,990. New mean equals new total sum divided by number of observations. Equals 4,990 divided by 100. Equals 49.90. So, the correct answer is 49.90. A distribution consists of three components with frequencies 45, 40 and 15 having their means 2, 2.5 and 2 respectively. The mean of the combined distribution is. The options are 2.1, 2.2, 2.3, 2.4. To find the mean of the combined distribution, we'll calculate the total sum of each component and then divide by the total frequency. Component 1. Frequency, F1, equals 45. Mean, M1, equals 2. Total sum, T1, equals F1 times M1. Equals 45 times 2 is equal to 90. Component 2. Frequency, F2, equals 40. Mean, M2, equals 2.5. Total sum, T2, equals F2 times M2. Equals 40 times 2.5 is equal to 100. Component 3. Frequency, F3, equals 15. Mean, M3, equals 2. Total sum, T3, equals F3 times M3. Equals 15 times 2 is equal to 30. Total frequency, F, equals F1 plus F2 plus F3 equals 45 plus 40 plus 15 is equal to 100. Total sum, T, equals T1 plus T2 plus T3 equals 90 plus 100 plus 30 is equal to 220. Mean of the combined distribution equals total sum T divided by total frequency F equals 220 divided by 100 is equal to 2.2. So, the correct answer is 2.2. Consider the table given below. The arithmetic mean of the marks given above is. The options are 18, 28, 27, 6. To find the arithmetic mean, we need to calculate the total sum of marks and divide it by the total number of students. First, let's find the midpoint of each interval. 0 to 10, 5. 10 to 20, 15. 20 to 30, 25. 30 to 40, 35. 40 to 50, 45. 50 to 60, 55. Now, multiply the midpoint by the number of students and add them up. Arithmetic mean equals total sum divided by total number of students. Equals 2,800 divided by 100. Equals 28. So, the correct answer is 28. The arithmetic mean of 5 numbers is 27. If one of the numbers be excluded, their mean is 25. The excluded number is. The options are 28, 26, 25, 35. Let's solve it. 5 numbers mean equals 27. Sum equals 5 times 27 is equal to 135. For numbers mean equals 25. Sum equals 4 times 25 is equal to 100. Excluded number equals 135 minus 100 is equal to 35. The correct option is 35.